Aimbot part 3.8. Today we complete the aimbot that with the tap of a key aims on the closest enemy's head. Thanks to the people that joined the stream last time. I had a fun time. Join me in the next. Alright. Welcome to part 3.7 or part 4. I don't know at this point anymore, but we're going to complete the aimbot, hopefully. So we will write all of the last functions and use the data correctly to make an aimbot in this part. In the last part we made a ReadEntity function which looked like this. So by using the entity base we read the ammunition, the health, the team, feet position, head position, name, and we return it as an entity, which is our own blueprint that looks like this. So that's pretty much it, but it took a while to create this. If you're up to speed, if you have done the previous tutorials, go ahead and do this with me. So let's continue. Need to drink some liquid first. Someone pointed that out in a previous video. It was pretty funny. But it's time to read all of the different entities. So read all of the entities in the entity list, getting all the enemies and teammates, and read or tell our program if it's an enemy or a teammate. Thereby we can draw the enemies red and the teammates green, and hopefully not use the aimbot on our teammates. That's also a plus. We will go back to our functions script, and below the ReadEntity method we will create a new public. Now this is a list because it's a list of entities, which is called ReadEntities. This ReadEntities will take one entity, and that will be the local player. Now, why do we use the local player? That's because we will calculate the magnitude to the enemy and maybe some view angles for the enemy, so we know what to aim at, and we can also calculate which enemy is closest to our view angles in that way. But let's start this up. So var entities equals new list entity. So this is what we will return, our new list. We want an entity list pointer, which equals to memory, our memory class, dot read pointer. And now we will read the module base and offsets dot entity list. So we have the pointer for the entity list. Now we will need to read another pointer, which will be the entity pointer for each entity, because the entities are you need to add an offset. So 4 bytes down, since 4 bytes is the size of one pointer, and it's 4 bytes aligned, which means at 4 bytes there will be one pointer, 8 bytes there will be another pointer, and so on. So we can create a for loop which does that for us. Int I equals 0, I is less than. Now I choose 4 here. If you are using more bots, just make this a larger number. But I will just use 4 bots. I know there is a value in game for the amount of players, which you can use here. So, no, here. So while I is less than maximum players, that way you will also always read all of the entities and nothing else. But to get the pointer of this current entity, create a new variable, current end base, which equals to mem.read pointer, and now we use the entity list and the offset I times 4 bytes. I think you can just do times 4, but doesn't matter. This will just, or as I said earlier, we will loop through each pointer. If all of this confuses you, then I suggest watching the Sheetanian video part 2, which where we find the entity list, and you can see on Sheetanian the pointers clearly. But when we have the entity base, we can use our ReadEntity method up here, and we read all of the information of this current entity. Now we have a lot of information. We have position, health, team, a lot of stuff, but we don't have the magnitude. So the entity.magnitude, which is a float field in our player class, entity class, my bad. And now, since we don't have a method for calculating the magnitude, we will have to create a new method. The method will be made down here. So public static float. That's because it does this stuff doesn't change, so we can use static. It will work either way, so do what you want. It's your choice. We will use the local player, and we will use the destination entity. So when we use it here, we will just use the current entity and then the local pair. But for the calc magnitude, we will return a float or a casted float, and here we will use a lot of math stuff. So math.square root. Why is it calling itself again? Or it's suggesting me to calculate magnitude once more. But we will use math.pow, which is the power to whatever you want. We need when you're calculating the magnitude, it comes down to a 8th grade math. You should remember this from school, but you get like a straight line in 3D space from one point to another, and the length is the magnitude. You can get that by calculating x squared plus y squared plus c squared, and take the square root of that. So if you want to calculate the distance, which is x, y, you just use power x squared and y squared, but we have 3 axes. Is that how you say it? Maybe not, probably not. But we have our dest entity dot feet.x minus our entity, because we're getting the delta x. plus let's move that down, plus math.pow dest entity dot feet dot y, and it completes it for us. And lastly, the z-axis. Why does it? This AI is giving me the wrong answers, even though I have wrote it twice here with different fields. It still gets it wrong. But I don't really mind. Okay, the z-axis. And there we go. So now we have calculated the magnitude. We will return the magnitude here, so calc magnitude. And as I said earlier, local player and the current entity. All right. Do we have? Nah, we don't have to calculate the angles yet. Let's filter out some immediate entities. So if their health is below 0, we just don't keep them. We're not interested. If ent.health. This is where you use the dead offset rather than the health offset. So if you have that, good for you. Ent.health. And entities dot add ent. There we go. So if the player is alive, pretty much, your maximum health is 100, I believe. We still haven't returned our entity list, so return entities. This should read all of the entities in game. Let me check that in Assault Cube. Single player, bot settings, idle bots, of course. Deathmatch, doesn't matter what difficulty. Deuce. And here we have all of our friends. No. That's annoying. Let's test this application. So go back to your form1.cs because we haven't called the function yet. In your form1.cs, we now want list entity, and we call it entities again. We will want to use system.threading because we're using system.threading. We're creating a new thread that will do all of the work for us. So reading the entities, drawing everything, and not freeze the window. I mean, we could just call it here. So entities equals read. My bad. m.read entities, and now we use the local player. So now we should get these 3 guys. Let's test it. entities. Count three entities. It's looking good. Here we have the name. That's a weird name. That's looks more like a name. So Slatopramen and Killer. I think I saw Killer here before. So that's Slatopramen. Yeah, that is his name. So Defaced was his name, and Killer. So now we have successfully read the entity list, and I got into health, got into positions. The current time was wrong. No one cares. We have the team, and we can check if there are different teams. So this guy is another team, probably our team, since he is the odd one out, and I should be his teammate. Then it would be 2 against 2. Let's close that one down. Delete the breakpoint, and now we could, yeah, let's start working in the form1.cs. So this area. In the form load, we will start our new thread that will do this, all of this, 24/7. So it will loop and read all of the entities, read the local player, check if we're holding our aim key for our aimbot, and all of that stuff. Thread. We'll call it thread. My imagination is bad. We will need a method, so here will be our method. Let's call it main. Our main function. So in main, it will be in the background. This makes it so when you close the application, everything closes down and not just the window. It can run in the background if you don't add this. So we start the thread and cut this out, not needed. We will add it in here instead. So now this will loop through and read the local player first, then the entities. Okay, we do thread.sleep 20 milliseconds. Here we can do entities equals entities dot order by O equal or greater than O dot O for object. Please, why? Oh my. Just let me. Oh, it's spelled wrong. Dot magnitude to list. So this will filter from low to high magnitude, which means you will get the lowest or the nearest character. Now that was my headphones that died. That's cool. Let me get my charge cable. I bumped into the microphone. Alright. I'm back again, and after we have ordered our entities by the magnitude, we will check if we're holding our aim key down. So in C# you will have to import a certain user32.dll. So in the top under the class write dll import user32.dll. This will give you an error because we don't have system.runtime.interop services. So add that to the usings part, and after that write static extern short get async key state. So we get the information if a key is down. And you can specify the key. Get async. Oh. There we go. Get async key state to no. And then parenthesis keys dot, and you can choose whatever button you want. I will use my X button 2, which is the mouse 5. And it's below 0. After we have checked if our mouse key is down, we can check if entities is greater than 0, so we don't try to aim on an entity that isn't there. Then loop through entity in entities. Let's call it ent for short. After this, we check if ent.team does not equal our team. We will shoot them. So we haven't calculated the angles for us to aim at the enemy, which is a crucial part in making an aimbot. So let's go back to our functions and create that calculate angles. So the calculate angles method will be returning a vector 2. So I think we will need to import using system.numerics. There we go. And we'll call it CalcAngles. So it will use our local player, and then the entity or the enemy that we want to aim at, so the destination entity. You can use 3D coordinates, it doesn't matter. Create X and Y. This is what we will return when we have calculated the angles. So we will need delta X, which is the head position, or the head X versus or minus our head X. There we go. And delta Y, you guessed it, Y position. Now to calculate the X view angle, it will equal to, we'll cast it as a float because we're using floats. And now we will use math.atan or tan tang, whatever you call it. I'm not studying in mathing anymore, so I don't care. But think of it as a triangle. So you have the like a flat surface. You have x and you have y. You have one position and the other. You take the delta to get a triangle between you and the destination entity. With that triangle, you can just get the angle by using atan. So when using atan, it's the delta y and then the delta x. And we do this times 180 divided by pi, because it's in radians, right? Yeah, I think it is. You can hover over atan2, returns in radians. So to convert radians to angles, or there's a certain name. Euler angles. I don't know, but angles, degrees. You use 180 times, or divided by math.pi. So now when calculating the y, we need delta z, which we get from the destination entity, head c minus our z, and we get the distance. So instead of writing the whole distance thing all over again, we can create a new method that returns our distance. So public static calc distance takes the entity local player and the entity just entity. Here we return float, and now instead of the magnitude we just use x and y. So we can just copy this when I think about it. And we need to add that parenthesis. I forgot to add the data type. Now that we have a method for getting the distance, we can just call it here. So calc distance, local player, and the dest entity. Now for the y angle, y equals and float. Oh, I forgot. And the x angle, it's offset by 90 degrees. So if you would calculate the angles, it would be 90 degrees to the left instead of on the target. That you will just have to test your way to find that out. But it's offset by 90 degrees, and you can fix it like that. So the y angle, it will be a float, and we use atan again. Here we use delta z and the distance, and times 180, we're turning it into degrees. Return new vector 2 and x and y. So now we have the angles, finally. We have the angles for the, or we have the new angles. Now we just need to write to the game's memory these new angles between our character and the entity. And we can do that with a new function. So we can call this method aim. So take our entity. You could use this to change the or other entities view angles, but we will use it for our entity. Here we can now use the vector 2 because we will get vector 2 by calculating the angles here. And call it xy. So now just do mem.write. Oh, never mind. Because we don't have vector 2 in the memory class yet, we will just do float x and float y. That's my bad, because we don't have the vector 2 memory data type in the memory class yet. So we use the write float for now, and base address, the entity's base address, and offset dot view angles, and then the new float value, which is the x. Now we copy and paste. This time it will be the y, and the y angle is 4 bytes below the x because it's a vector, and a float is 4 bytes, so we can just add 4 bytes on the view angles offset, and of course use the new y value instead of the x. Let's go back to our forms script, and now calculate the angles for the entity that we're looking at. Use the methods dot calculate angles, the local player and the entity. Now use the aim method to aim our local player at angles dot x and angles. So this would look better if we just had a vector 2, but whatever. After that we break, so it will aim at the first entity that's closest and not a teammate. After that it goes back, it breaks out of this one, right? Yeah, breaks out of this one, and yeah, all right. Are we done with the aimbot? How long did I record for? 33 minutes. Okay, I thought I was fast, but that's just a lie. Let's test it in game. So start it. Remember your aim key, minus mouse 5. Okay, nothing's happening. Amazing. When nothing happens, I can teach you some error fixing. Just add a breakpoint to where you think you're supposed to get. Hold your aim key. If it doesn't get here, oopsies. Doesn't seem like it's finding any enemies somehow. Should find entities. Let's add a breakpoint here. Does it actually run into the thread? No, okay. So you see that I added breakpoints, but it didn't break. Means it's not running this. Is it because it's supposed to be does not equal null? It is. Okay, so there was some organic error fixing, which I did fix within time, not to have to cut the video. I'm proud of myself, but let's try it again, now with no breakpoints, because we want the application to run. And hold our aim key. Okay, so you can see now that we're aiming totally nowhere, which is also an error. This means probably that I'm calculating some very weird view angles. I will get back on this one. I don't think I can fix this one as easily as the breakpoint issue. So I'll be back. Alright, so I think I saw what the error was in our offsets. The view angle is not supposed to be 28, is it? Our feed is 28. Let me find. So this is our notepad. The view angles are at 34. Let's change that to 34. Also, I wrote angles.x twice here. So, wow, amazing. Let me find the bots again. There we go. Please don't teleport me to nowhere. Alright. It looks like we're in business. Kronborg is getting blasted. And the good thing is it's not aiming at our teammates. Now, when we have the aimbots, we have the entity information. We have all of the stuff. No, we don't have the view matrix. We will find that out in the next part. So we get the correct view matrix, and you can do that with the world to screen function. We just test these entity positions and so on into that world to screen function, and if it gives out the correct points, the points should be on the enemies and teammates. If they give the correct ones, we could use that for our view matrix. But I hope that you guys could follow this video. We made 2 errors. No, we made 3 errors. But that's all part of coding. You will have to live with that. Thank you guys for the ones who joined the stream last time. We had lots of fun. Even though it was really short. I streamed for 55 minutes and then I had to go. But don't know when I will stream the next time. Come join me anyways. Have a good one.